Let's see how we go about testing for the means with two samples using StatCrunch. When we look at comparing the sample means from two different samples, if they are simple random samples from normally distributed populations, we do not know standard deviations for the populations, and we do not assume that they are the same. Then we'll use a t-test. Here they are giving us the data for the two samples. This is asking us to compare the average weight of cans of diet soda versus cans of regular soda. We're going to use a 0.01 significance level. Our claim is that the contents of the cans of diet soda have weights with a mean that is less than the mean for the regular soda, because they're on a diet, I guess. So the diet soda is the first sample. So if the weight from the diet soda is less than the mean for the weight of the regular soda, then that means mu1 is going to be less than mu2. First one's equals, of course. So let's go with this. Nice. Now to do this in StatCrunch, if I pull up StatCrunch, I'm going to slide it over here to the side. I want to go, this is going to be a T. So T-stats, this is going to be two samples with the summary. Sample mean for the first sample. Sample standard deviation for the first sample. Sample size, 36. Next sample mean, 0.80511. Next sample standard deviation, 00757. Sample size, also 36. Now, as long as we are not assuming that they have the same standard deviation, we will not pool the variances. So I don't think you're ever going to need to click on this, but if it said assume they have the same standard deviation, but you're not actually given a standard deviation, then you pool the variances from the two samples to combine them. Hypothesis test must be correct. The first one's going to be equals, of course, always. The second one in this case is a less than. Compute. So our T statistics give 7.68, 2 decimal places. Thank you. P-value is less than 0.0001, so just put in 0. Since the probability is 0 that the null hypothesis is supported, then obviously we reject the null hypothesis. So there is sufficient evidence to support the claim that the cans of diet soda have mean weights that are lower than the mean weight for the regular. Now, I don't remember running into a problem with this for the proportions. So I guess all of the proportion problems were two-tailed tests. But if you have a one-tailed test, when you switch from the hypothesis test to the confidence interval, you have to double your significance level before you subtract it from 1. So we're going to hit options, edit. We're going to change it to the confidence interval. But for the 0.01 significance level, we will double that to a 2, subtract that from 100%, so this becomes 98. And this is really important. There are some samples where the standard deviation is so low that it doesn't make a difference. And then on other problems, it does make a difference. So it's better to be careful every time. So compute, So for our confidence limit, our confidence interval, the lower limit is negative 0.015, rounded to 3 decimal places. The upper is negative 0.008. Notice that if I had left this at 99, would it have made a difference in this case? 0.015, the upper limit would have been off. So it would have made a difference. Does the confidence interval support the conclusion? Of course, before we concluded that the probability was 0, we would reject the null. Here, because this does not contain 0, we're saying that the means are different, that their difference is not 0. So yes, this does support it because this contains only negative values, which tells us not only that we are going to reject the null hypothesis, basically, but that we're saying that the first mean is smaller than the second mean, so that when you do the first minus the second, you get a negative number every time. In this problem, they give us the data for one sample, which has where they have the IQ scores for a group with medium lead levels in their blood. And then they give us the statistics already calculated for a second sample of people that have their IQ level with high levels of lead in their blood. As we see here. Now, StatCrunch can either do 2 samples where they have the data or 2 samples where they have the statistics, but not one of each. So since we can't take the second sample and convert it back to the data, we're going to have to find our mean, standard deviation, and sample size for the first set. So let's load this into StatCrunch. And to get that information, we're just going to do stat, summary stats. It's in a column. Pick the column. We could just pick all 4 of these. That's faster. So we have, let me write this down. N1 is 11. X bar 1 is 90.272727. S1 standard deviation is 10.000909. Now let's switch back to the t-stats, 2 samples. Now we have the summaries. So the first sample mean was 90.272727. Standard deviation 10.000909. Sample size is 11. The mean from the second set is 88.016. Standard deviation 9.751. Sample size 11. Do not assume the population standard deviations are equal. It says that right here. So compute. Oh, did I check the hypotheses tests? Wait a minute. Let's back up and make sure that's right. Don't need this. I've got all the data in. Okay, what is the claim here? Assume the 2 samples are independent sample random samples, normally distributed. Here's our claim. Test the claim that the mean IQ scores for subjects with medium lead levels is higher than the mean for subjects with high lead levels. Okay, so medium is the first sample, If the first sample is higher than the second, that's a greater than. So equals, 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 equals and greater than. Boom. The test statistic. Make sure these match. That's an absolute must. Test statistic is 0.536. Oh, wait, 2 decimal places. 0.54. Probability, 2 decimal places, 0.299. 0.299 is higher than anything they would have, I'm sure. Let me clear this out. 0.01, way, way, way higher. Okay, so we're going to keep the null hypothesis. Fail to reject. There's not sufficient evidence to support the claim. Okay. Confidence interval. This is a one-tailed test. So again, when we switch to the confidence interval, we have to double the alpha, which was 0.01. So make that 0.02 from 1 is 0.98. Lower limit here is 0.839. Left out my decimal. Upper limit 12.90. Does it support the previous conclusion? Yes, because the confidence interval contains 0, which means that the two means, the difference between the two means is nothing, 0. One more problem. Here, I'm only going to show you how to set this up and get your data, because the rest of it is exactly the same as the rest. We have time intervals between eruptions of a geyser. Assume the recent times within the past few years, the past times are 20 years ago. Assume the two samples are independent, simple random samples selected from normally distributed populations. Do not assume the population standard deviations are equal. Does it appear that the mean time interval has changed? Now, this doesn't indicate whether they're looking for increased or decreased, just changed. So this is going to be a two-tailed test where we're saying the two means are equal or they're just not equal. This means on the confidence interval, we will not double the alpha values before subtracting them from 1 to get the confidence intervals. And to load this into StatCrunch, just hit the little boxes here, open in StatCrunch. We'll go with stat, tstats, to samples with data. First values are recent, second values are the past. Compute, boom. So it's the same as the other problems. Got it? Let me know if you have any trouble. I will see you later. Take care. Bye.